Okay, so we're going to look at unit circle. We've already seen this before if you guys remember it, but a unit circle is a circle with radius 1 unit and center at the point 0, 0 or the origin, right? So if this is my coordinate plane, say this is my x-axis, this is my y-axis, then my unit circle would be that, where my points on the circle here would be 1, 0, 0, negative 1, negative 1, 0, and this point here would be 0, 1, right? So here, this is my center, which is 0, 0, and my radius is going to be 1 unit. So if you think about your equation of a circle, you're going to get x minus 8 squared plus y minus k squared equals r squared. So I get x minus 0 squared plus y minus 0 squared equals 1 squared. And so I get x squared plus y squared equals 1. So that is going to be the equation of your unit circle. So anytime I say unit circle, you have to think about this equation, which is x squared plus y squared equals 1. Now, what is the circumference of this unit circle going to be? Well, we know that circumference is 2 pi r, but for us, radius is just 1, so circumference is just going to be 2 pi. So for a unit circle, the circumference of that circle is 2 pi. So we're going to talk about symmetry here and how do we find points on a unit circle using symmetry. Now, think about your unit circle again. Here's your unit circle, right? And from the graph, we can see that it is symmetric about the y-axis, it's symmetric about the x-axis, and it's also symmetric about the origin, right? So we're going to use these symmetries to find points. So suppose I'm given a point. If pxy is a point on the unit circle, then we can find 4 other points on the unit circle using symmetry. And the 4 points are the following. So suppose this is a point pxy, right? And you can pick this in any quadrant, but I'm just going to pick it in the first quadrant for now. So if pxy is a point on my circle, the first point that I can find on my circle is px negative y. And how can I find this? Because I know the circle is symmetric about the x-axis. So if I flip this down here, if I reflect it down here, this point here is also going to be a point on my unit circle. And so this is reflection about the x-axis. Okay, so that is one point that I can find, and that point here would be p x y. Okay. The second point that I can find is p negative xy. And how do I find that point? Well, we know that this unit circle is symmetric about the y-axis. So if I reflect it about the y-axis, if this point is here, then this point that is negative xy also has to be there. So this is reflection about the y-axis. Okay. Then the third one, and if you remember, I said this is also symmetric about the origin. So if this point is here, then its counterpoint, that's going to be p negative x negative y, right? Because if I come to the third quadrant, then all my variables, all my coordinates rather, are negative, and so then I know that the point negative x negative y, I should name these differently. So I'm going to call this r. We call this S and T, right? And this is we get by reflecting about the origin. And finally, we have the point u, y, comma, x. Now, the good thing about this circle, the unit circle, is that it's also symmetric about the line, and I'm going to draw that line a different color. If you all remember this, the line y equal to x. Okay, so if you remember from inverse functions what the line y equal to x is, and since it's symmetric with the line y equal to x, if I switch the points around, the coordinates around, then there's also going to be a point on my unit circle, and this is reflection about the line y equals x. And so in this case, this point would be somewhere around here, and that would be my point y comma x. Okay, so using symmetry, we can find 4 different points on the unit circle. So let's take an example and try and find points using symmetry. Okay, so let's look at this example. We have a point 1/2 and √3/2. So first thing we're going to figure out is this point on the unit circle. If it is not on the unit circle, the second part of the question doesn't apply to us because we cannot use symmetry. But if it is on the circle, then we can use symmetry of the unit circle then to find 4 other points, right? So how do we check if this point is on the circle or not? So we know that our unit circle is of the form x squared plus y squared equals 1. So if I plug in this as my x and this as my y, right? So that's my x coordinate and y coordinate. If I plug those 2 values in here, I should get 1. If I don't get 1, then it's not going to be on my unit circle, right? And so if it comes out to be less than 1, then we can say that that point is actually inside my circle. And if you put it in here and this comes out to be greater than 1, then my point is going to be outside the circle. Okay? In those cases, we cannot figure out anything using symmetry. So first of all, let's go ahead and put those points. We get 1/2 squared plus √3/2 squared. Now what do I get? I get this is 1/4 plus 3/4, and that is 4/4, or 1. So it checks out that x squared plus y squared equals 1, which means that is a point on the unit circle. Now using symmetry, right, I need to find 4 other points. If you remember, one of the points we had was, so we have xy equals 1/2 and √3/2. One of the points that we could find was x negative y, and that point is going to be 1/2 negative √3/2. Okay. Another point we had was negative xy, which is negative 1/2 and positive √3/2, right? So these are my 2 points. This is a reflection about the x-axis. That is a reflection about the y-axis. The reflection about the origin would be your points negative x and negative y, and those would be my points negative 1/2, comma, negative √3/2. And finally, my reflection about the line y equal to x, where basically I just switch the x and y coordinates, and so that's going to be √3/2, comma, 1/2. So since that point is on my unit circle, I can use symmetry, right, and I can find 4 of the points on my unit circle as well.